Hey folks, so I want to do a quick proof of the product rule. We've been using it for a little while now, so let's actually prove it. So let's let f and g be differentiable. So that's what we need in order to show that, well, then their product will also be differentiable, and we'll show how you compute that derivative. So eventually, when we make the statement that f and g are differentiable, we're going to appeal to their limit definition in order to show the limit definition for the product. But that'll be a little ways down the road. So let's give it a shot. So we're going to say then that the derivative of the product function f times g of x, well, that's just equal to the limit as h approaches 0 of f times g of x plus h minus f times g of x all over h. Folks, this first line might seem a little confusing. All I'm doing here is using the more abstract way of talking about the product of two functions. But you know what it means to multiply two functions together. What is f times g? Let's say over here. What is f times g of x? Why, it's f of x times g of x. So we'll do that in this next step. So this is the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x all over h. And if you had done this for your first line, that would have been perfectly fine. Okay, so the big trick in doing the product rule with the limit definition is right here. I'm going to say that's the limit as h approaches 0 of, and what I'm going to do is inside this fraction here, I'm going to add and subtract the same term. So this is f of x plus h times g of x plus h, and then here's where I'm going to insert that term. I'm going to write minus f of x g of x plus h, and then I'm going to add that same term, f of x g of x plus h minus, let's go back to the red, so minus f of x g of x all over h. So all I did here from the line above it was subtract this term and then add that same term right back in. So in effect, I've added 0 in the numerator of the fraction. And that's a common trick in math. Okay, so let's keep working with this. The next thing I'm going to do is I'm going to say, well, hey, let's say you had a plus b over c. I could rewrite that as a over c plus b over c. So what I'm going to do here, that's just from the definition of fraction addition, right? If I want to add these two fractions, I simply add their numerators over the common denominator. So what I'm going to do here is I'm going to break this fraction up right here into two separate fractions. So let's go ahead and do that step. So this is the limit as h approaches 0 of f of x plus h, g of x plus h, minus f of x, g of x plus h, all over h, plus f of x, g of x plus h, minus f of x, g of x, running out of room there, f of x, g of x, all over h. So inside of this large limit expression, what did I do? Well, I took this one single fraction, and as I said, if you had a sequence of terms, say you had a plus b plus c plus d all over h, I rewrote it as a plus b over h plus c plus d all over h. So all I've done is broken this fraction up this way right here. I wrote it as two separate fractions. Okay, let's zoom in just a little bit on that. Okay, so what can I do now? Well, I can go ahead and let's take this property out on loan. Let's go ahead and distribute this limit over this sum here. So this gives me the limit as h approaches 0 of f of x plus h, g of x plus h, minus f of x times g of x plus h all over h, that's h there, plus the limit as h approaches 0 of f of x g of x plus h minus f of x g of x all over h. So all I did here between this line and this line was distribute the limit over the sum, which is something that we're allowed to do. Well, I guess eventually we'll have to show that these underlying limits exist. Okay, so my next step is to, I'm going to do two steps at once here just because I want to keep this video short. Notice that I've got, in the numerator, I've got two factors here of g of x plus h. Notice that? So I'm going to pull these g of x plus h factors out of the fraction, and then I'm going to actually distribute the limit over the corresponding product. So that gives me the limit as h approaches 0 of g of x plus h times the limit as h approaches 0 of f of x plus h minus f of x all over h plus, and then over here, notice that this term in the numerator has a factor of f of x, and this term in the numerator has a factor of f of x, and f of x, since our limiting variable is h, f of x does not change as h changes, so we can say that it's constant in the limit, so we can go ahead and factor it out. Okay. So we're very close to being done here. Notice that what I've done here is built the limit definition of the derivative of f, and I've built the limit definition of the derivative of g. So we're getting close. Now, so in fact here, I'll go ahead and say, well, that's f prime of x plus f of x, that's this f of x right here, times g prime of x. Again, that's this limit definition. And we knew that g prime of x existed, and we know that f prime of x existed because, well, in our statement of the problem, we said assume that these two functions were differentiable. Okay, so we're almost done here. The last sort of nagging step is, well, how can we evaluate this limit? Well, what I'd like to do is do direct substitution on it. I'd like to be able to say that that is g of x plus 0, and then finish out the problem. Let me ask you a question. How do I know I can do direct substitution on this function? So that's something to pause and think about. I'll give you a hint. Actually, I'll just tell you the answer. So we assume that g is differentiable. And remember we said that differentiability, we did this in section 3.2, we said that differentiability implies continuity. So because we know that g is differentiable, it's also continuous. And when you've got a continuous function, it means that evaluating the limit at any point is the same thing as evaluating the function at that point, i.e. you can do direct substitution. So at the end of the day, what have we done? Well, we started with two functions, f and g. We knew they were differentiable, and so then we found the derivative of their product. So the derivative of the product exists, and this is how you do it. So remember, that says that if you take d dx of f of x times g of x, how do you take the derivative of the product? Well, it's the second function times the derivative of the first plus the first function times the derivative of the second. And there we have our product rule. If you have any questions, let me know.